we're going to be talking about something very important that, believe it or not, could actually one day make you rich. And this is the concept of being able to learn the difference between simple interest versus compound interest. So, what do I mean by this? Well, if we're talking about simple interest, then this is actually able to be defined as, let's take simple interest and call it S, and let's say that that's going to equal the principal times the rate times a unit of time. So let's go ahead and name all these variables. So S equals simple interest, and P equals the principal, R equals the rate, and by the way, you're going to commonly see this expressed as APY, which is your annual percentage yield, if that's what you're earning, versus APR, which is your annual percentage rate, and that's what you would pay somebody who would be giving you some kind of a loan, and you would have to repay them a certain amount in return for the privileges of being able to take out that loan. And X equals some unit of time, could be months or years or however you want to think about it. Probably it would be pretty instructive to think of it in terms of years, but if this is just a simple interest, then that's not actually accounting for the fact that you would also have to pay back the original principal on top of that, or if you were the one giving out the loan, then this is what you would be receiving. So let's call this total amount A, or A of X would equal your principal plus your principal times rate times X, because we have the principal plus your interest S, so let's say that equals P plus PRX, okay? But notice here, this is a form of an equation that you should be able to recognize. We have some kind of mx plus b term here, so this is what we would call a linear equation. Okay. Now, what about compound interest? Well, compound interest is an application of your exponential equation, which is of course given in the form of y equals a times b to the x, and if we want some kind of exponential growth, then b has to be greater than 1, because if it equals 1, then 1 to the x won't be anything other than 1 times a, or just your original a back, and if b is less than 1, that's going to be how we're going to come up with our exponential decay. So, and exponential decay has a number of applications in itself, but that's not what we care about here. So, knowing this, to come up with a compound interest equation, I like to think of it like this. So your compound interest amount, or let's say your C of X in total is going to equal your principal times 1 plus rate divided by your number of compounding periods per unit of time to the power of your number of compounding periods per X unit of time. So N would be number of compounding periods per unit of time X. Okay, so we can see that our A, or what we have initially, is represented by the principal once again. Our B is represented by our 1 plus R over N, and our exponent is NX here in this case. So this is going to be an exponential equation once again. And if we look at the graph of what this would look like, let's say on the x-axis we have our time, and let's say we're going to have our f of x on the other axis here, and we're going to have some principal point here, and that's going to have, well, that can be described by the point 0 comma p, because at time 0 we're going to begin at the principal, and if we go like this, then this is going to be our A of x equation. Notice it's a straight line, because this can be directly written in a linear form, and in the meantime, our compound growth equation is going to look something like this. At first, it's going to be pretty close to our simple interest one, but if you give it enough time, the interest is going to compound on the interest, and it's going to start to run away, and there's going to be a noticeable gap that's going to grow ever larger here. So that's our C of x, and our A of x can be described by this here, where if we want to think about what the slope is, think rise over run. So it's got to have a rise of PR for every 1 unit of time that we have here. So, okay, so this is how this works, and yeah, so I could make a different video talking about the history of how these systems were thought of and used over time. They both are still used, but probably more commonly you're going to hear about the power of compound growth, which Albert Einstein is supposedly have said to have called it the, quote, 8th wonder of the world. But yeah, so basically compound interest, it's been known about for a few thousand years, and they have tabulated the values in early tables for several hundreds of years, but it was really kind of frowned upon for a long time as usury, because people thought that charging additional interest on top of interest was unreasonably high of a debt to whoever the borrower was going to be. But it's actually become commonplace nowadays for a lot of different types of things in the financial world. But okay, if you can understand how this works and you can invest a certain amount of your income every month, for example, and you set it aside and you don't touch it, and you put it in something with a reliable rate of return, one day when you go to retire, you could be very rich. So if you don't learn much of anything else, you should know how compound interest works. So, okay, hopefully you found this helpful, and I'll see you in the next one where Joe shows you how.